Good afternoon, everyone, and welcome. My name is Rudy Page, and I'm pleased to introduce our next community wellness dialogues, and we'll be focusing on HTLV 1, and it's about raising awareness, improving community understanding, and then giving the call to action message. And I'm really pleased in terms of opening up this series of dialogues, because in the UK, there's more than 22,000 people who are infected with the virus HTLV-L1. And the majority of these people come from areas such as Africa, the Caribbean, or the Windrush generations, as we know them here in the UK, South America, in particular Brazil. And so in this series of dialogues, we'll be speaking to an NHS consultant, HTLV researcher, and some African Caribbean patients. So I'm really pleased that we have Professor Graham Taylor. He's the head of section of biology, at Imperial College London. He's also a consultant physician at St Mary's Hospital in Paddington. Good afternoon, Graham. How are you?
Hi, Rudy. Very well, thank you. Thanks for inviting me.
Thank you. Tell us a bit about the HTLV infrastructure as is.
Yeah, so as you said, I'm based at St Mary's Hospital in Paddington, which is part of Imperial College Healthcare Trust. And about 20 years ago, we were able to set up a dedicated clinical service for people who are infected and affected by HTLV-1. This was with Central Department of Health funding. It's centrally funded. And we started small, pretty much a sort of almost a one-man band. But we also felt that it was important not just to be based in London. Everything is based in London, but we wanted to get out and share what we were learning. And so we have also got clinics with colleagues in Birmingham, in Manchester, and in York. York covering the northeast of England. But the biggest clinic by far is our clinic at Mary's, and we're called the National Centre for Human Retrovirology. But we're really focused on HTLV infections.
Okay, so tell us, what is HTLV-1?
Okay, so it's a virus. I'll spell out what its name is, and I have to confess that we've confused everybody by giving it two different names. Fortunately, they have the same letters. So we mostly call it human T lymphotrophic virus type 1, but we also call it human T leukemia virus type 1. And it's had those names over the years, and we're trying to nail it down to just one name, but at least it's always HTLV-1. And it's a virus that has been around for a long time. It's not a new virus. It's not a SARS-CoV-2 just come out of nowhere. This is an ancient virus which has been around for not just centuries, but for actually tens of thousands of years.
Okay, so what diseases does it cause, and does everyone develop the disease?
Yeah, good question. So the first thing I guess to say is not everybody develops an obvious disease related to HTLV-1. In fact, the majority of people don't develop one of the HTLV associated diseases, which I'll talk about in a minute. But what we are learning is that there may be more subtle consequences of the infection. And because this virus, once we're infected with it, it stays with us for the rest of our life. we have to mount an immune response to it to keep it under control. And we think that is contributing to a number of health problems which don't shout out, hey, HTLV1, but actually impacting on people's long-term health. But to get to the things that we commonly think about when we think about HTLV1, there is a blood cancer, a leukemia, which is called adult T-cell leukemia, and that is 100% caused by HTLV1. If you don't have HTLV1, you do not get this leukemia. So it's very important because it directly causes a leukemia. But the majority of people do not get that leukemia. But we reckon 5%, so 1 in 20 people infected would develop that leukemia. The other type of problem is inflammation. And it comes back to what I was saying earlier about when you're infected with something, a bacteria or a virus in this case, you mount an immune response. And we understand now, and I think as a population, we understand better the importance of the immune response sometimes causing health problems rather than the bacteria or the organism. And that's certainly the case with HTLV1. It causes inflammation, which can cause a number of problems over a period of time. So it's not an immediate problem. You don't become infected and immediately develop a problem. It could be years later, it could be decades later. The one that everybody is most familiar with is an inflammation of the spinal cord, which we call a myelopathy. And because it's linked to HTLV, we say it's HTLV associated myelopathy. And we abbreviate that to the 3 letters HAM or HAM. But that condition, long before we knew about HTLV1, was recognized under a different name, particularly in the Caribbean, where it was called tropical spastic paraparesis, or TSP. So sometimes we stick the two names together and talk about an inflammation of the spinal cord called HAM-TSP. But there are other systems where inflammation occurs. It can be muscle, it can be lung, it can be the thyroid, and just really a range of problems. There is a third element that we see sometimes in the UK, but we see a lot more in the tropics, which is where somebody is infected with HTLV1 and another organism. So, for example, people who maybe live somewhere where TB is common and also have a HTLV, there's an interplay between the two infections, which can make one or other more difficult to manage. So there's a range of things that can happen: a leukemia, inflammation, or an interrelationship with other infections.
Okay, so how does infection occur and can it be avoided?
Yeah, so infection occurs in several different ways. So I'm going to start with the youngest time point where one can be infected, which is in the womb. It's possible if you are a baby and your mother is HTLV1 infected, that you can become infected even before you're born. And that occurs in a very small percentage of babies whose mothers are carrying HTLV1. Much more risk to the baby is when they are being breastfed, because the virus is within the cells, within the breast milk. And as the babies are breastfed for longer periods of time, they are more likely to become infected. And in fact, in situations where mothers are breastfeeding for longer than 1 or 2 years, 1 in 3 babies will become infected. And this is really important because there is an opportunity to prevent that transmission from occurring completely, which we can talk about more. After the child has stopped breastfeeding, we know from looking at in studies of families that there is no further transmission in childhood. So this is a really important thing. The virus is not being spread just around a house. It's not being spread by people sharing a cup or a plate. And then we see new infections occurring once people become adults, and particularly once they become sexually active. So the second main reason why people may become infected with HTLV1 is because they have intercourse with somebody who has HTLV1. And the virus can pass from one person to another through sex, not through kissing, but through sexual intercourse. Now, the thing about this virus is it's in blood cells, in white blood cells. So anything where white blood cells are involved, which includes, for example, blood transfusions or organ transplants, that if the white blood cell is there and they are infected with HTLV1, if a donor is infected, the recipient may become infected too. So that's the third major way of transmission, through blood passing from one person to another, whether it be in a medical procedure or, for example, through people sharing equipment when they're injecting drugs for recreational purposes.
Okay, and avoidance?
So we start with the baby. If the babies are not breastfed, then they are not at risk after birth of becoming HTLV1 infected. And that actually prevents 80% of all the infections in babies. So if we were to know that a mother was carrying the virus, infected with the virus, and thinking about breastfeeding, simply by describing, what may happen, what there's a virus, what might happen to the baby if it got infected, and making choices about infant feeding, then if we choose to avoid breastfeeding, if we go for formula feeding, then that first risk is prevented. And that's really important, because there's a more, if you've been infected, if you're infected for a long time in your life, you've got more chance of developing problems related to the virus, particularly the leukemia. If we move on to the adult life, then dealing with, first of all, the transmission through sex, there are the barrier methods that we advocate for preventing transmission of other infections will work for HTLV1 as well. But what we know is that they're not always used, and they're not used because people don't know that they're carrying the virus. They don't have any symptoms, they don't have any signs, nobody's told them they have it, so why would they worry? And then the third element where we do have prevention in the UK is with the blood donors. They're all screened when they first start to donate blood. So we identify people who are infected, and they're advised that they carry a virus, and they're advised not to donate blood. Similarly, we screen tissue donors, organ transplants screened. And so that does prevent some infection, but obviously it's a relatively small amount compared to the number of infections occurring through breastfeeding or through sexual intercourse.
Yeah. So where did it come from?
Yeah, like I said, it's an ancient virus. And like so many of our infections, there is a different host initially. And in the case of HTLV1, that host is a non-human primate. In other words, it's coming from the monkey world. And there was an identical virus in monkeys, which is called a simian virus, as opposed to a human virus. So it's called an STLV rather than an HTLV, but they are identical. And So what's happened in the past and continues to happen is that when people are in contact with other species, in this case, other non-human primates, if they get bitten, or if they are scratched, or if there is any exchange of blood or white blood cells, probably through hunting primarily, that allows the transmission from one species to another. Once it's jumped, it established itself in the human population. And we can see that this happened a long time ago. I mean, we're talking 20 to 40,000 years. And from one of the things we can see is where did it start? Well, it started in West Africa, and then it spread over thousands of years. And what we know, for example, is there's HTLV1 in Australia. There are no monkeys in Australia. So the virus went with its human carrier, and the indigenous people of Australia arrived there 20,000 years ago. So it's been with them all that time. I worked in the Solomon Islands, and that's where I first came across HTLV1. That's Melanesia, and it's just to the north of Australia. People have been there for 5,000 years, and they have HTLV1. Some of those people had no contact outside of the Solomon Islands until the last century. HTLV1 is there, and so we can kind of map out how HTLV1 has spread around the world at different times. And of course, the most recent migrations, if you like, are very modern ones where people jump on an aeroplane. But before that, it was ships, and before that, it was people literally walking.
Yeah. So, is there any treatment after infection has occurred?
So we don't have a treatment for the virus itself. We would love to have something like that, but it's quite a difficult problem, because the virus infects a cell, but not only infects the cell, it gets into the genetic code of the cell, and then it becomes quiet. So the genetic code of the virus is copied in a certain way and inserts itself into genetic code of a cell, and is then invisible. When that cell, as it will do, divides to make its next generation, and so on, and it keeps dividing, that genetic code of the virus is also being copied. So you now have 2 cells, 4 cells, etc., with the genetic code of the virus silent. And it's only when that genetic code is read and the cell machinery starts to make proteins related to the virus, instead of proteins related to humans, that we see it as something foreign, and we need to do something about it. So that's the problem we have, is how do you target genetic material which is already established? It will be easier to prevent the infection than it is to get rid of it once the infection has established itself.
Okay. So is there any treatment for the diseases which it can cause?
Yeah. So I'll take the 2 main types of condition I described earlier and deal with them individually. So first of all, we have the leukemia. Now, what we know about the leukemia is that it's important, first of all, to diagnose it as early as possible. And we may talk about that a bit later on. Once we know that it is that particular leukemia, it's really important because how you manage it is a little bit different from other leukemias. And then what we go down is a route of standard chemotherapy, as you would for other malignancies of white blood cells. And then if you can get a good response from that, you have an opportunity to do what we call a transplant treatment. So where we replace the infected person's white blood cells with a donor cells. Now, obviously, that's not an easy thing for somebody to undergo, but it does provide an opportunity for cure in that setting, which is something we didn't really talk about just a few years ago. Ideally, we would like to prevent both the infection, but also in the longer term, we'd like to prevent, if somebody is infected, the leukemia developing in the first place. In terms of the inflammation, and particularly I'm going to talk about the spinal cord inflammation, because that's the thing we see most. We have to tackle the host response. So we have to deal with the inflammation, which is the response to the virus. And we, as I said, we can't get rid of the virus. So we have to dampen down the host response. And it's really important, again, that we identify the problem early, because the sooner we can start doing that, the better it is. So we do that with things like corticosteroids and treatments which are used, for example, in rheumatoid arthritis. We use a very similar methodology. We don't have all the same drugs, but the approach is similar. But again, it's important that we make try and get the diagnosis early. And one of the problems we see in the clinic is the delay that we have from somebody first presenting with some symptoms which are due to the virus causing this inflammation, and somebody actually, a medic making a diagnosis and saying, oh, this is due to HTLV, because nobody knows they've got HTLV.
Right. So it does beg the question why we haven't heard about it before, and why isn't there a prevention program?
Yeah, I struggle with that question. I think the simple answer is timing. HTLV was first discovered in 1980, probably technically in 1979, but the papers came out in 1980. And that was around the same time, 1981, as HIV came along. And we didn't know what the cause of HIV. We didn't know what was going on. When AIDS first came along, nobody knew what the cause was. So in 1983, another virus was identified. And that turned out to be the cause of AIDS, and is called HIV. Now, if you look what happened, there was a lot of interest in HTLV1 in 1980 through to early 80s. And then suddenly the whole problem was HIV. Mm-hmm. And HTLV, people felt, well, most people aren't getting sick. We have maybe I don't know if they thought this, but I think the actual consequence was the focus went on HIV, which was, affecting a large number of people, but having a much more immediate and visible impact on people's health. So that I think is the first thing. And then I think after that, it's been quite difficult to explain why the medical profession have really not sort of risen to the challenge of it. And okay, there's things like cost of screening programs, but nobody even did the cost analysis to say it's too expensive, we can't afford it. There just hasn't been that engagement with it. And we're trying to change that. Good. And, you're trying to change it, but we're all working to try and change that and make sure that people do understand that just because you haven't heard of it doesn't mean to say it's not important.
Yeah, and of course it's important to the people who suffer and their families and population groups where it may have a disproportionate impact.
Absolutely. And I think globally, if you look at where HTLV is, with the exception of Japan, which is a high income country with a high rate of HTLV in its population. If you look elsewhere, if you look at Europe, North America, the rates overall are relatively low. And then when you look for where is it more common, you mentioned it, Caribbean, South America. We don't even hardly ever hear about it in Africa, but we know there are millions of people infected with HTLV1 in Africa. And so they're in settings where there isn't enough resource in the medical arena. They're not necessarily screening blood, so we're still getting transmissions through things where we could do prevention. And there's certainly not, there's not screening, for example, in the antenatal setting, or when people go for a sexual health checkup. So the vast majority of people who are infected are unfortunately also living in areas where the health resources are not there to plow into health in general, never mind into an additional problem. We're pleased to say that Brazil is holding up the flag there and making progress and recognizing it as a problem. But this is a very recent development.
So what advances are being made?
So I think we've got some new information from research that's been ongoing over a number of years now, in that, first of all, we've known for a long time how to prevent mother-to-child transmission through avoidance of breastfeeding. But apart from people using condoms or barrier methods to protect against infection through sex, there hasn't really been anything to offer. We know now that some drugs, antiviral drugs, will prevent transmission. They've not been tested formally in clinical trials like we would do for other viruses like HIV, like hepatitis. But we know that in the lab, they block transmission, and we know how they do it. So I think one of the advances we are starting to talk about is saying, well, let's see what information we can gather on their effectiveness in the community from potentially from studies that have already been conducted where they didn't look to see the effect. And I think we do have tools to prevent transmission if we would only apply them. Where infection has already occurred, to me, we need to improve treatment, yes, but if we can prevent or treat much earlier, we will be doing much better. And the areas where we're, I think, making quite big strides now is being able to sort out, identify people who are at most risk of developing some of these health problems. Now, that's a kind of double-edged sword in a way. If you tell somebody, well, I told you you didn't have a very high risk, but now I'm telling you, actually, you've got a higher risk than some of the other people. We have to balance that. But that's important if you can do something about it. Yeah. And I think we are getting to the point now where we're going to test a treatment that is used in the treatment of the disease that's already developed to actually prevent leukemia, which would be an amazing advance. And we've got good reason to be optimistic that this treatment will reduce the number of infected cells, and in particular, reduce the number of cells that could become leukemic cells. Similarly, with the inflammation, we can now identify people who have that inflammation but haven't yet developed the clinical consequences of it, at least not in a way that we can detect. And those people will benefit from much closer monitoring and investigation, and again, potentially very, very early treatment. So we're not trying to treat somebody who is having difficulty walking already, but before they even have those problems, if we know that that's what is going to happen. So I think there's hope on all fronts, but we can only do these things if we know that people have got the virus. And that is a real problem for us, because most people don't know they have the virus.
Absolutely. So finally, you have already touched on in terms of who's infected, and which certain population groups. So could you just say a bit more about the diagnosis for people who may be concerned that they don't understand?
So in some ways, I mean, diagnosis of HTLV1 infection is relatively straightforward. It's a blood test. It's the same as, so a pregnant lady going to an antenatal clinic, she undergoes a whole range of tests. She'll get tested, for example, for hepatitis. The same type of test, which is absolutely routine, is available for testing for HTLV1 as well.
Is that on request though, or is that?
Well, you might struggle even if you requested it. Depends where you go, but it's certainly not being offered.
Yeah, well, that's the point, isn't it? Really?
That's the point. It's not being offered. Now, this comes down to a national decision that has to be made. And this is where the people who are going to pay for it need to know, well, what are we going to get if we invest thousands of pounds to screen every pregnant lady for this virus? What's the chance we're going to find somebody who's infected? And what are we going to do about it? And how much will it cost? But also, how much money will it save in the longer term? And the data emerging that actually it is going to be cost effective to do it. So it's not just like being the right thing to do. It could be the right thing to do financially for the health service as well in the longer term. So diagnosis, from a medical point of view, diagnosis is easy because we have the tests available, tried and tested, very sensitive. So in other words, they don't miss anybody, but also very specific, which means they very rarely get it wrong, which is always the thing when we're doing diagnosis. And these tests are very good. So they're available, we're just not offering them or recommending them. And that really is the next step in terms of diagnosis. That's at the antenatal setting. After that, we would like to think that people attending for a sexual health checkup, it will be included there. You don't have to have any sexual health problem. You don't have to have a sexually transmitted infection to be infected with HTLV1, because you may have picked it up as a baby. But you can pass it on. And if you don't know you have it, how do you avoid passing it on? And how would you avail yourselves of the things that are going to develop that will prevent transmission? So, yeah, we need to make a diagnosis.
Okay, so thank you very much for that. Professor Graham Taylor, Head of Section Biology at the Imperial College London, also a physician at St Mary's Paddington. That has been really most informative. And I'd like to thank you very much and talk to you again very soon, I hope.
Thank you. Thank you for the invitation again. Thank you. It was really good talking to you. And yes, I'd like to carry on with this dialogue later.
Bye.
Bye.